Welcome back to Models and Agents, episode 24 for April 1st, 2026. Let's see what happened in the AI world today. And trust me, it's been busy. Here's what's making news in the Models and Agents world today. Hugging Face just shipped TRL version 1.0, finally turning the messy post-training pipeline into a stable, production-ready, unified API. At the same time, Liquid AI dropped a surprisingly capable 350 million parameter model that makes you question whether bigger is always better. And we have a strong wave of new RxEV papers delivering practical techniques for continual pre-training, memory architectures, quantization, and scientific reasoning. Plenty to dig into, so let's get started. The top story today is Hugging Face releasing TRL version 1.0. This marks the transition of the library from a research-oriented codebase to a stable, production-ready framework. The new version codifies the entire post-training pipeline into a single standardized API. That includes supervised fine-tuning, reward modeling, and alignment using both DPO and the newly supported GRPO. For practitioners, this unification is genuinely exciting because it eliminates the friction of juggling separate scripts and versioning headaches. You can now maintain one coherent stack instead of switching contexts between different alignment stages. Teams building fine-tuned models or preference-optimized agents should pay close attention. This is the kind of infrastructure improvement that saves weeks of engineering time. If you have been maintaining custom alignment pipelines, the new Unified Trainer API should feel like a breath of fresh air. I would start by installing TRL version 1.0 and migrating an existing DPO or SFT script to the new interface. Keep an eye on the emerging GRPO examples as this reinforcement learning variant gains traction. Now on the model side, Liquid AI released LFM 2.5 350M. This is a compact 350 million parameter model trained on 28 trillion tokens. That is a significant jump from the previous 10 trillion tokens thanks to additional pre-training and large-scale reinforcement learning. Rather than chasing raw scale, the model serves as a case study in intelligence density. It shows that careful data scaling and reinforcement learning can extract surprising capability from smaller architectures. This is particularly interesting for teams deploying on-device or latency-sensitive applications. When parameter count directly impacts cost and speed, models like this become very attractive. It is a refreshing counterpoint to the usual bigger is better narrative. Another standout model-related release is Polar Quant, a new post-training quantization method. Researchers introduced Polar Quant using blockwise normalization, Walsh-Hadamard rotation, and Gaussian-matched centroids. The interesting part is that Hadamard rotation alone delivers 98% of the quality gain. It reduces Chuen's 3.59b perplexity from 6.90 with ABSMAX Q5 down to 6.40. That is only 0.03 above the FP16 baseline. It also serves as an excellent pre-processing step before INT4 quantization with Torcheo. The practical takeaway is clear. You can now quantize aggressively with almost no quality loss. This should be useful for anyone running 7 to 13 billion parameter models in production. We also saw Optimer, a new method for post-hoc optimal data composition in continual pre-training. Optimer decouples data mixture ratios from training by training one continual pre-training model per dataset. It then extracts distribution vectors and uses Bayesian optimization to find ideal composition weights after the fact. On Gemma 327b, it outperforms traditional data mixing with 15 to 35 times lower search cost. The same vector pool can be re-optimized for new objectives without retraining. This feels like a smart engineering win for anyone doing continual pre-training across languages and domains. Shifting to agent developments, Apex EM brings a non-parametric online learning approach for autonomous agents. It introduces a structured procedural episodic experience replay system. This lets LLM agents accumulate, retrieve, and reuse plans without updating any weights. The workflow is plan retrieve, generate, iterate, ingest, using hybrid retrieval with both semantic and structural DAG matching. The results are impressive, plus 48.3 percentage points on KGQA Gen 10K, reaching 89.6% versus 41.3%. It also shows plus 29.4 percentage points on Big Code Bench. This is one of the strongest demonstrations yet that explicit memory architectures can dramatically improve agent reliability. If you build agents that repeat similar tasks, this direction looks very promising. There is also a new neuroscience-grounded memory framework for human-like lifelong memory in agents. It draws on complementary learning systems, valence vectors, belief hierarchies, and dual-process cognition. The architecture defaults to fast System 1 retrieval with System 2 escalation. It converges toward cheaper inference as experience grows. While still theoretical, the 7 functional properties give a concrete blueprint for building truly lifelong agents. This is the kind of paper that will influence the next generation of memory systems. On the practical and community side, Crosstrace delivers 1,389 cross-domain grounded reasoning traces. These cover biomedical, AI, and machine learning, and cross-domain topics with step-level verification. Fine-tuning Schwinn 2.57b. Instruct on this data using QLoRa dramatically improves hypothesis generation quality and structural compliance. Balanced cross-domain training outperforms single-domain training, suggesting scientific reasoning patterns transfer well. This is an excellent resource for anyone building research agents or scientific co-pilots. Another practical release is LightCoST for long document question answering. It uses a 2-pillar approach with chain of structured thought traces generated by a strong model. Those traces are then distilled into 3 billion and 7 billion parameter small language models using supervised fine-tuning plus GRPO. The result achieves comparable quality to large models on multi-domain long document QA. At the same time, it delivers 2 to 4 times lower latency than GPT-4o or DeepSeek R1. The GitHub repository is already available if you are tired of throwing massive models at noisy documents. Finally, MemoryRank offers preference memory for personalized product re-ranking. It distills long purchase histories into concise, query-independent preference signals for LLM shopping agents. The memory extractor is trained with reinforcement learning against downstream re-ranking performance. This approach improves 1 in 5 selection accuracy by up to 10.61 points over raw history and no memory baselines. Strong evidence that explicit preference memory beats simply dumping history into context. Okay, let's pop the hood on this heuristic override phenomenon in LLM reasoning. Everyone talks about LLM's reasoning as if they perform logical inference like humans. In practice, they are heavily driven by surface heuristics that can completely override implicit feasibility constraints. Certain salient cues like distance, cost, efficiency, or semantic similarity create strong sigmoid-shaped influences on model output. Token-level attribution shows these decisions look more like keyword associations than true compositional reasoning. One study found the distance cue exerts between 8.7 and 38 times more influence than the actual goal in the car wash problem. The heuristic override benchmark reveals this is widespread. Under strict evaluation, no model exceeds 75% accuracy across 14 tested models. Presence constraints proved particularly difficult, with only 44% accuracy. Interestingly, adding a minimal hint emphasizing the key object recovers plus 15 percentage points on average. This suggests the failure is in constraint inference rather than missing knowledge. Current post-training heavily rewards surface patterns that correlate with correct answers during training, even when those patterns conflict with deeper logical structure. For your own reasoning pipelines, always include explicit precondition enumeration steps. Goal decomposition prompting recovers 6 to 9 percentage points. For high-stakes domains, consider hybrid systems where a smaller verifier model checks for heuristic override patterns. The gotcha that bites most teams is assuming high benchmark scores mean the model is actually reasoning rather than sophisticated pattern matching, so when should you reach for extra guardrails versus trusting the model? Use them whenever the cost of being wrong is high or when the task involves implicit constraints that are easy to miss. Things to try this week. Try the new TRL version 1.0 unified API for your next DPO or GRPO project. The standardized pipeline will save you significant integration time. Experiment with PolarQuant on your 7 billion to 13 billion parameter models. The Hadamard rotation trick gives near lossless Q5 quantization with almost no calibration data needed. Test LightCoST on your long document QA tasks if you want GPT-4o quality at 2 to 4 times lower latency using 7 billion parameter models. Play with ApexM style structured memory on repetitive agent tasks. The 29 to 48 percentage point gains on benchmarks suggest real productivity improvements are possible today. Fine-tune a small model on Crosstrace if you are building any kind of scientific or hypothesis generation agent. On the horizon, expect more production-grade GRPO implementations and examples following the TRL release. Continued research into non-parametric memory systems looks likely as both Apex EM and the lifelong memory papers gain attention. We will probably see further work on heuristic override mitigation techniques now that the HOB benchmark gives everyone a clear measuring stick, and watch for additional intelligence density-focused small models as liquid AI's approach challenges conventional scaling wisdom. Before we go, tomorrow keep an eye on further developments around production GRPO tooling now that the foundation is stabilized. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This podcast is curated by Patrick but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy and I hope others do as well.